Have you ever wondered what it would be like to travel through time? To journey back to see history unfold before your very eyes? Or to rocket into the future and witness the marvels of technology yet to come? Buckle up, because today we're diving deep into the mind-boggling realm of time travel, exploring the tantalizing possibilities and the scientific principles that might just make it a reality. Get ready to have your mind blown as we uncover some incredible facts about time travel that will leave you questioning the very fabric of our universe. You know, humans have always been fascinated by time. Ancient myths, legends, they all grapple with the concept of time travel. But it was H.G. Wells and his iconic time machine that really ignited our collective imagination. Suddenly, we weren't just telling stories about time travel, we were exploring its possibilities, its paradoxes, its sheer mind-bending potential. Think about it, the power to witness pivotal moments in history, to right past wrongs, or to get a sneak peek at what the future holds. It's a concept that's captivated storytellers, scientists, and, let's be honest, all of us at some point in our lives. Films like Back to the Future played with the idea, showing us both the thrills and the potential dangers of messing with the space-time continuum. And who could forget the epic adventures of Doctor Who traversing time and space in that iconic blue police box? But time travel isn't just the stuff of fiction. It's a concept rooted in some of the most fundamental principles of physics, principles that we'll delve into right now. Now, to grasp the mind-blowing possibility of time travel, we need to turn to the mind that revolutionized our understanding of the cosmos. Albert Einstein, his theory of relativity, particularly special relativity, is like the rule book for how time behaves, and it's far weirder than anything we could have imagined. You see, Einstein showed us that time isn't this rigid, unchanging thing we perceive it to be. It's relative, meaning it can actually speed up or slow down depending on how fast you're moving relative to something else. Think of it like this. Imagine two identical clocks, one here on Earth and another on a spaceship zooming through space at incredible speeds. Einstein's theory predicts that the clock on the speeding spaceship would actually tick slower than the one on Earth. This phenomenon, known as time dilation, has even been experimentally verified. Scientists have flown atomic clocks in jets around the world, and guess what? Those clocks came back ever so slightly behind their earthbound counterparts, just as Einstein predicted. Now, this might seem like a tiny, insignificant difference, but it has profound implications. It means that time is not a constant, it's fluid, and it can be warped and stretched by things like gravity and velocity. And that warping, my friends, opens the door, at least theoretically, to the possibility of time travel. Chapter 3. Paradoxes of time don't meet your past self. Now, before you jump into your DeLorean and hit 88 miles per hour, we've got to talk about some of the wrinkles in the fabric of time travel, the paradoxes. These are thought experiments, puzzles really, that highlight the potential logical inconsistencies that arise when you start messing with the past or the future. One of the most famous is the grandfather paradox. Imagine, if you will, traveling back in time and accidentally, or not so accidentally, depending on your feelings about your grandfather, preventing your grandparents from ever meeting. Think about it. If they never meet, they never have your parents, and you never exist. But if you never exist, how could you have gone back in time to cause the paradox in the first place? Mind-bending, right? These paradoxes have led some scientists to believe that time travel, at least to the past, might be impossible. However, others have proposed solutions, like the idea of parallel universes. Maybe, just maybe, when you travel back in time, you're not actually changing your own past, but creating a split in the timeline. A new branch of reality. It's a wild concept, but then again, so is the very idea of time travel. Chapter 4, Time Travel Experiments, Bending Reality. So, we've talked theory, now let's talk reality, or at least the reality of our attempts to understand and maybe even manipulate time. While we haven't quite built a working time machine yet, scientists have conducted some pretty mind-blowing experiments that hint at the potential of time travel. Take, for instance, the work being done with particle accelerators, these massive machines that smash atoms together at nearly the speed of light. These collisions generate so much energy that they can actually create tiny black holes, regions of space-time where gravity is so intense that not even light can escape. Now, black holes themselves are still shrouded in mystery, but some physicists believe they could hold the key to unlocking wormholes, theoretical tunnels through space-time that could connect distant points in the universe, or even different points in time. Imagine stepping into a wormhole here on Earth and emerging on the other side billions of years in the past or future. It's a concept straight out of science fiction, but it's based on real, albeit highly complex and still theoretical physics. And then there are the experiments exploring the strange world of quantum mechanics, where particles can exist in multiple states at once. Some researchers believe that by manipulating these quantum states, we might be able to influence the flow of time on a microscopic level, perhaps even sending information back to the past. Now, we're still a long way from sending humans through time, but these experiments demonstrate that we're pushing the boundaries of what we thought was possible, inching closer to understanding the true nature of time itself. Chapter 5. The Future of Time Travel, a Journey Unfolding. So where do we go from here? The future of time travel is as wide open and mysterious as the universe itself. Will we ever perfect time travel technology? Will we build spaceships capable of warping space-time or unlock the secrets of wormholes? Only time will tell. But one thing is certain. Our fascination with time travel is not going away. It will continue to fuel our imaginations, drive scientific inquiry, and inspire us to explore the furthest reaches of our universe and beyond. Perhaps one day we'll be able to look back on this moment, on the cusp of discovery, as the dawn of a new era in human exploration. An era where the boundaries of time are no longer barriers, but gateways to new adventures and unimaginable possibilities. Until then, keep questioning, keep exploring, and never stop looking up at the stars and wondering what secrets they hold, what mysteries of time and space are just waiting to be unraveled. Because the universe is full of wonders, and who knows what incredible discoveries await us just beyond the horizon of our understanding. Keep dreaming big, my friends, and keep your eyes on the stars. Time travel remains one of the most intriguing concepts in science and fiction. The possibility of witnessing historical events firsthand or catching a glimpse of the future is a tantalizing thought. While it presents numerous paradoxes and challenges, the quest to unravel the mysteries of time travel continues to inspire scientists and dreamers alike. Who knows, maybe one day we'll be able to journey through time ourselves. Until then, keep dreaming and stay curious.